Our topic is what is the next innovative technology in space exploration? The people who worked on this project are David Woodruff, Anthony Servino, Matthew Folds, and me, Alyssa Davis.
What is the next innovative technology in space exploration? There are many sectors of developing technologies which are being stimulated by growing interest and investment in the space sector, most significant of which are the current propulsion and fuel technologies which create a need for more innovation. Since the beginning of time, man has gazed into the heavens, and developing technologies will one day grant us access to the furthest stars. As aspiring engineers, we are dedicated to the pursuit of perfection, and in this conquest, we too find ourselves gazing into space. The universe holds a near infinite number of resources, and the finite deposits of valuable commodities on Earth hold no candle. As we grow as individuals, and as a species, we only strengthen our need to travel to the stars.
Alright, so the innovations in space for fuel and propulsion is actually kind of an interesting story, as there's some pieces of technology that were introduced a pretty long time ago that actually aren't being utilized, and vice versa with things being utilized that necessarily weren't discovered too long ago. So I'm going to jump into fuel first. There's actually now a green alternative to rocket fuel called acronym GPIM. It's actually going to be tested in SpaceX in the SpaceX Falcon Heavy launch that's coming up pretty soon, later in December, I believe. And it is comprised of hydroxyl ammonium nitrate, and obviously you need an oxidizer for its combustion, but it's all green. Compared to hydrazine, which is being used now, it's actually the most common form of rocket fuel, which is toxic to humans, and you actually need a lot more of it. It's a lot less efficient than this new GPIM alternative, about 50% that is. And also one downside actually to it would be that we need to create new hardware for it, as it's not necessarily being introduced yet, but an example of that is actually found in propulsion. I'm going to move on to propulsion now, in GPIM propulsion. So this uses that the hydroxyl ammonium nitrate with an oxidizer for the combustion in the makeup of it, and it's actually using 5 regular 1 Newton thrusters in a propellant tank. So it's a standard layout, but it's new technology in the sense it's going to be able to use the feature of fuel. So then we have the Raptor engine. Those are being used on the SpaceX launches. Mainly, it's actually liquid methane fuel. Another form of coming propulsion is ion propulsion, but this is kind of interesting because ion propulsion was actually introduced quite a long time ago, and it's essentially a very low thrust, but extremely efficient rocket. So I think they compared it to the force of a piece of paper hitting your hand is the amount of thrust, but it is such an exponential increase when in space with such an efficient use of fuel that you could theoretically infinitely accelerate something. And then finally we have solar sails. These are a more known upcoming piece of technology that use that catch photons to propel basically space pirate ships. So thank you very much.
Terraforming is changing the atmosphere and the surface of a planet to be more similar to Earth's. Before terraforming can occur, there are some pre-terraforming steps, including the checking the levels of water, CO2 or carbon dioxide, ice caps, and the nitrates on Mars. Terraforming has 2 stages. The first is warming Mars to be the average temperature of Earth, and then back down to about 15 degrees Celsius. That process would only take about 100 years or less. The second process is to add enough oxygen to the atmosphere to allow humans and other large mammals to breathe on the planet, and this could take about 100,000 years. Terraforming can help to put humans and other mammals on Mars, which seems to be the next frontier in space travel.
Self-sufficiency. Self-sufficiency in space is a very important topic. If we cannot create resources that can be harvested or use existing resources in space, then the human race will always be dependent on resources from Earth. One of the points of the space program is to bring new resources to Earth and create a way for humans to continue living when Earth has been depleted of all its resources. Companies such as SpaceX, Blue Origin, and NASA have all been doing research on genetically modifying plants and other resources to make them more efficient and sustainable in space. NASA and other companies also have engineers trying to create a sustainable biodome. NASA has done research on trying to make solar-powered satellites that send energy back to Earth to help reduce the amount of fossil fuels used. The types of engineers that participate in all these activities are genetical engineers, mechanical engineers, architectural engineers, and aerospace engineers.
So let's talk about food. Current space technologies regarding food are quite limited in nature. Dehydration is one of the big things that we have, and that's how we've been able to transport food for our astronauts and then have them eat it in space. However, that's certainly inadequate when we're coming up with ideas like going to the moon and Mars, where supply missions wouldn't be as feasible on such a regular basis. So that brings us to the issue at hand. How do we make food in space? And what type of food would you make in space? So what we would want are compact production, low water production, should be able to survive in zero gravity, and have relatively high radiation tolerances. And the food itself needs to be nutritious, have a long shelf life, be compact, and have a low water content for easy storage and use. NASA's done some research into how to make food in space, and that'd be the Veggie 1 and Veggie 3 experiments. Both of them were targeted at growing plants on the ISS and seeing the feasibility of growing food in space. Both experiments were very promising, and the plants grew very well. Using nutrient packs and water, just like on Earth, plants grew just fine. They're very adaptable in nature. However, plants don't supply everything that an astronaut and a human would need to consume, which brings us to the question of what else can we have for food? Which brings us to my two solutions. First of which, cultured meat, is an astounding field which is growing rapidly. Using the biomatter from a single cow, more than 5 million burgers can be produced, which is insane in terms of production. And in space, it'd be pretty easy just to get a petri dish and, under the right light and nutrient conditions, grow meat. That also brings us to my second one, insects. While it may sound a little bit gross to most of us, insects are actually a very promising source of protein and nutrients in general. They take 33% less than beef to produce, nutrient-wise, and it's a very effective way of feeding ourselves. So in the future, we may just be growing our meat out of petri dishes or eating bugs.
In March 2019, Vice President Pence, the chairman of the National Space Council, announced that the moon landing would occur by 2024, and in May 2019, the NASA Administrator Jim Bridenstine announced a new program would be called Artemis. Currently, there's only one planned mission to Mars based on the NASA government website, which is to put a new rover there to collect samples for future recovery to Earth. The Mars rover is also going to be looking for fossils, which could point to previous life on Mars, which indicates the possibility for future inhabitation.
In summary, as people keep trying to innovate to decrease the cost of space travel and increase the yield from resources gained in space, there will be a constant flow of new research. Most of the research done is connected to making the vehicle more efficient and increasing how long a person can be in that vehicle. Most jobs require Most jobs connected to space exploration require a baccalaureate in sciences.